What's up? I'm Diamond, and today I'm gonna teach you what this thing is. Breadboard. What a breadboard is. Let's go! Okay, we're not going anywhere. We're staying here. So luckily for you, I got this thing. This will make explaining a lot easier. It's not like I can use an iPad to draw or anything, or make an animation. Well, I paid for a board, we're gonna use it. I'm just gonna put it away for a minute. We're gonna use this a lot for our Raspberry Pi tutorials. Basically, this thing is very useful when you're setting something up, when you're just playing with sensors or something like that. This is very necessary, and we need to understand how it works to continue. So first of all, just the theoretical idea of what a breadboard is. Basically, it's just a piece of plastic that has connections going one way or another through these pinholes. So you can see better. Don't know why I left all this white space here. Just to obstruct the view, I guess. You know, just imagine this is the top of the breadboard. So now I'm going to explain to you how this works. The markings, the letters, the plus and the minus, you can actually ignore that. They don't really serve any purpose. The only things you have to understand is that the breadboard is split down the middle. That means that the two sides of the breadboard, they aren't connected. That's one thing. Another thing is that the plus and minus on each side are connected in this way. So if you pass electricity to any of the pins here in this row, every single thing in this row will have electricity flowing through it. Same thing goes for minus. Minus also connects this way. You don't necessarily have to pass in minus there, you can just pass in the current here as well. Vice versa on the other side, I don't need to explain that. The plus and the minus columns on each side, they connect vertically. The letter columns on each side of the board, they connect horizontally, which means that all of these pins are connected, all of these pins are connected, these, and so on and so forth, as well as these.
6.5 hours later.
The rows don't connect, sides don't connect, which means basically that if you pass electricity here, these 5 pins will have current flowing through them. If you pass electricity to any of these pins, these 5 pins will have the current flowing. But it doesn't mean that if you pass electricity here, it's not going to light up the rows nearby it. As well as it's not going to pass electricity to the other side of the breadboard. This allows for you to install resistors, for example, between pins over this gap. So we will go through one live example of how this works on the actual breadboard. Yay! I'll explain it on this board as well. This is a pretty simple concept actually, I'm sure you'll understand it. Alright, so I have the real thing set up here conveniently next to our picture so we can both set up an example and analyze on the picture what I'm doing. I'm not gonna repaint the picture because that took most of the day here. Alright, so we're gonna need something to connect. So naturally, when setting up a Raspberry Pi, I mean, you gotta use an LED. When connecting an LED, we will also need a resistor because we don't want to burn our Raspberry Pi. And we're going to need a couple of wires, one to pass the current to the breadboard from the Raspberry Pi and then another to return to the ground pin. So we need to pass the current from the Raspberry Pi to the breadboard, and then we need to ground the current. So for that, we will be using these GPIO pins on the Raspberry Pi. So if you remember in the previous video, I said that this is going to be super important. So this is actually very useful. I will explain what this is in a later video, but keep this, don't throw it away. This is basically a schema for the GPIO pins on the Raspberry Pi, telling us which pins are ground pins, which pins give a constant current flow, which pins we can turn on and off, and so on and so forth. So basically I'm going to use this to figure out which pin is going to be passing the current. So for the sake of this explanation of how to use a breadboard, I'm going to be using a constant current flow of 5 volts and we'll also be using a ground pin. I don't know if you can see very well here, but basically we have pins 2 and 4 that pass a constant current of 5 volts, and then we have pin 6 that is a ground pin. We can use any other ground pin as well if we want to, but I'm going to use pin 6. You have to look at the Raspberry Pi with the GPIO pins at the top right corner, and that's when this is going to correspond correctly. Pins 2, 4, and 6 will be these first 3 pins here. So 2, 4, 6. I'm going to be doing the current flow from pin 2, and then the ground is going to be 6. So let's go ahead and set that up. So I connected my wire to pin number 2. Now I want to pass current from Raspberry Pi onto the breadboard. Now I can do this anywhere I like. It just depends where I plug it in. So if I plug it in here, it's going to turn on this row. If I plug it in here or here, it's going to turn on this vertical row. So trying to not get too technical here, I need to pass the current from the Raspberry Pi to the cathode of the LED, which is the long leg on the LED. Then between the anode which is the short leg, and the ground, there needs to be a resistor. So the way we're gonna do it basically is this. I'm gonna connect the current flow to, let's say, row 25, to the horizontal row. Let's turn to the board here for a second. Let's imagine that this is row 25. So I'm gonna be passing the red wire here. This means that this whole row will have current flowing through it. Now remember, we need to only pass the current to the cathode, to the long pin. So this means that I have to connect an LED, one leg to one row and another leg to another row that doesn't have current flowing through it. So I'm gonna do it like that. Now, okay, we need one more row. This is where I connected the LED's long leg, and this is where I connected the LED's short leg. So long leg gets the current flowing. So now from the short leg, we need to add in a resistor. So let's go ahead and do that. All right, so I hope you see this okay. We're gonna explain it on the graph again. So I connected the one leg of the resistor to row 26, which has the short leg of the LED. And now this is important. The next leg of the resistor needs to go into another side or another row of the breadboard. Let's take a look at this drawing to better understand what's happening here. Let's say this is a long leg of the resistor, and this is a short leg of the resistor. When the current is flowing to this whole row, the resistor's long leg is going to receive the current. It's going to flow through the LED, a magical drawing of an LED.
You are so beautiful to me.
The current is going to flow from this row through the LED and back into the bottom row. So now the bottom row also has current flowing, it just goes through the LED. Which means if we connect the resistor here, we cannot connect it on the same row because that's not going to do anything. The current's going to flow straight through the row, which means that we need to move another leg of the resistor either to another row or another side of the breadboard. So I'm going to move it to another side of the breadboard. So let's imagine that's the resistor. I'm going to connect it here. That's exactly what I did here. The whole flow of the current is basically this way now, and we end up here. So this means that this is having the current at the moment and it's coming through the resistor, and we need to return the current from here into the ground pin. So we basically plug in our ground wire here and return it to the Raspberry Pi's ground pin, which is exactly what I did here. So now we have the full circuit finished. We can try and plug in the Raspberry Pi, turn it on, and we should see this LED light up. All right, the moment of truth.
Holy moly!
Yay! There we go. Now I know what you're thinking, that's confusing as shit, and you're right. That's why I'm gonna draw everything from scratch.
Oh God! No, God, please, no! No!
Just to reiterate and understand it better. All right, let's imagine this is the middle of the breadboard. We used 2 rows for the sake of this, so let's simulate 2 rows here.
A few moments later.
2, 1, 2. Also, I'm gonna use the pins, so let's call this 5 volts, and let's call this ground. This pin, when we turn on the Raspberry Pi, it gives out a constant current flow of 5 volts. What this means that if we connect a wire to this thing here and then move it over to this row, it's gonna enable this whole row. Remember, because rows, horizontal rows are connected and vertical rows are connected on the breadboard. So this whole row now has the current. Next thing that we have to do is we need to connect our cathode leg of an LED, because the cathode is the one that receives the current flow. So we connect the cathode here, and we need to connect an anode leg of the LED somewhere where the current is not, flowing, because we would short the LED otherwise. If we were connect an LED anode here and the cathode here, it's just gonna blow out our LED. So we move it down to another row. So that's where we connect the short leg, the anode. Okay, so our LED goes through here. Let's draw a nice LED here for you. Let's call it LED. All right, current comes in here, LED receives it, flows through the LED. Next thing that happens is this row gets the current outflowing from the LED. So we need to reduce that current now before returning it to the Raspberry Pi. And we do that by using a resistor. Now, if we were to connect a resistor's one leg on this row and another leg on the same row, nothing's gonna happen because the current's just gonna flow through the same line. So we need to connect one leg of the resistor into this row to receive the current, and we need to move it over to somewhere else where there's no current, so we can move it over to the other side of the breadboard, or we can move it down if we want to another row, but in this scenario we moved it to the other side. So that's our nice looking resistor. So now the current after flowing through the resistor, reduced current is flowing on this row, and now from this row we have to return everything to the ground pin. So we basically connect our ground wire anywhere on that row and we connect it to the ground pin of the Raspberry Pi. This is our whole current flow. I know that there are schemas, I could draw those for you, but I don't want to get too technical. So I hope this clears things up a little bit. So that's how the breadboard works. I probably made it a lot more confusing than it should have been, but I hope you do understand the concept of it. Of course, nothing's gonna beat the fact of you actually taking one and trying to set something up for yourself. But the idea of the thing is pretty simple and pretty straightforward. So I hope this video was way more than enough for you to wrap your head around the concept of a breadboard. We can finally start doing something fun with this thing. I have a touch sensor in my left hand and I have a Raspberry Pi with an LED in my right hand. Naturally, when people start out with the Raspberry Pi, they go for the LED right away. But LED is a pretty simple concept. Let me know in the comments below which one of these two, LED or a touch sensor, you want to see in the next tutorial. Thank you for watching and don't forget to subscribe. Don't forget to subscribe.